This is a definition of an exponential form made up of a power and a base. So this piece is the base, and this piece is the exponent. And how you say it is a to the nth power. And this is how you have a definition of an exponential form. The next slides are all the properties of exponents. So you may want to pause and write down these properties. So here's the first property, a to the m times a to the n. What you do with these exponents, if they are the same base, is you add them. So off to the right, let's just do a quick example. Here's our examples. So we have 3 to the second times 3 to the fourth. Notice that these are same bases, so we can add their exponents. So 2 plus 4 is 3 to the sixth. And then what you can do is you can enter that into your calculator. Next property is a base, an exponential of base a divided by another exponential of base a. And what we do with these exponents is we subtract them, m minus n. So an example would be something like this. 5 to the fourth power divided by 5 to the second power. What we do is we subtract them. So 4 minus 2 is 5 squared. If you like to see it this way, 5 times 5 times 5 times 5, that's the numerator, and then in the denominator there's two of them, 5 and 5. And what happens is the 5's in these two pieces cancel out, and then we're left with 5 squared. All right, the next property is when you have a negative exponent. We don't want you to leave an answer with a negative exponent, so you can rewrite it as 1 over a to the n. So an example might look something like this. 5 to the negative 2 power. How you rewrite it is 1 over 5 to the positive 2 power. Another way is, let's say you have a negative power in the denominator. So like 1 over 2 to the third. And you want to rewrite that as a positive power, or as a negative power. You just flip it back up to the top. 2 to the negative 3. Our last property is when you have anything raised to the 0 power, it is 1. So an example would be like 5 to the 0 is 1. 3 to the 0 power, 1. X to the 0 power, 1. The next set of properties, there's 3 more on this slide. What we have is 2 exponentials raised to the m power. What you can do is think of this as like the distributive property. They can distribute in. So you have a to the m and b to the m. An example might look something like this. 3x raised to the second power. What we do is we distribute that in because there's multiplication going on. So it's going to look like 3 squared and x squared. Now 3 times 3 is 9. X times x is still just x squared. Property 6 is what we call the power to a power rule. It has a power raised to another power. So what you do is you multiply those powers together. An example would look like this. 2x raised to the third. What happens is these two pieces, the 2 powers, the x and the 3, will multiply to each other. So we have 2 and then x times 3, which is 2 raised to the 3x. Our last property is very similar to property 5, where we have a fraction. We can distribute this into both pieces. An example would look like this. What you do is you distribute that 3 to both pieces. So it looks like 5 to the third over x to the third. So 5 times 5 times 5 is 125. X times x times x is still just x cubed.